This is TWIS. This Week in Science, episode number 810, recorded on Wednesday, February 3rd, 2021. Humans are all thumbs. Hey everyone, I'm Dr. Kiki, and tonight we will fill your head with blackmail, symbols, and monkey talk. But first, thanks to our Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. What could be greater than knowing that you are alive? Life. That great thing that we are all experiencing right now. And what would be even better is to do something that you love with the rest of your life. Since we don't all want to be doctors or science news communicators or succulent farmers, we might need to figure out some other things that people can do. One great place to look for things to do is science. In science, there's a lot that needs to be studied. In fact, everything needs another looking at some point. There's pretty much no limit to what you could decide to study when it comes to science, because everything's on the table. To get a good idea of what's available, what you could study in science, we've put together this quick list of examples we call This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are here in the beginning of February, ready to talk about science. Doesn't feel like Groundhog's Day to me. Nope, no siree, Bob. We've got new science, new stories, and new excitement, curiosity, and fun. I have a bunch of stories about thumbs, wind, and feelings. Yes. What do you have, Justin?
I've got Martian mud pies. Earliest symbolic writing ever, maybe?
Good.
Freshwater oceans of the recent past. And let me hear your monkey talk.
Let me hear your monkey talk. Your monkey talk. All right. I want to hear it. I want to hear it later. Blair, what's in the animal corner?
I have singing crickets. I have blackmail. And I have the moon.
Oh, you brought us
like
the
the
moon?
Mm-hmm.
I like the moon.
Take a bite out of it.
No, you take a bite out of crime.
Oh.
You
Lasso the
deliver-
moon.
Lasso the moon. There.
Yes.
Bring it
Take a
down
bite
to
out of
earth.
an apple, unless it's
Now
has
we're
to be
getting
the
into
right apple.
Now we're getting into idioms and metaphors and fables and okay, back to the science. As we jump into the show, everyone, if you are not yet subscribed to This Week in Science, you can find us on YouTube, Facebook, on Twitch. Look for This Week in Science. You can also find us all places that podcasts are found, pretty much, I think. And you can find us at our website, twis.org. Ready for the science?
Yeah.
Yeah, let's do this. I've got a fable, an old story, Tom Thumb. Well, not really Tom Thumb. I have a story about humans' old thumbs. Turns out the human thumb goes back about 2 million years, according to a new analysis of thumb bones and physiology, but not just the bones, because that's the way that everyone's looked at them before. They've looked at...
That's what you can see. That's
It's
what's
what
left.
you can... Right, it's exactly. Soft tissues are not fossilized very easily, and so if we're going back in history to look at the leftover bones of our ancestors, you're not looking at, the fatty or the not fatty, the the bulky,
Fleshy.
strong, fleshy
Just
thumb
sweet, that
muscles
Yeah.
that are involved. No, you're not looking at those. You instead are just looking at the bones. You're looking at what is there and making inferences based on the proportions that the bones are sitting there in. So how long is the bone? How short is it? How do the joints look like they potentially interdigitate? What do we know about living examples of a particular species? So say humans or chimpanzees versus what can we kind of make up about these previous ancestors and their bones? Well, these researchers publishing in Current Biology on the biomechanics of the human thumb and the evolution of dexterity, they based on their new analysis, which is a tool that they have come up with that could potentially help analyses of all sorts of different interdigitations and dexterity analyses moving forward. They have taken soft tissue into account for the first time. They have looked at a very specific muscle in the thumb, and it's called the musculus opponens pollicis. And this particular muscle, we know it's in humans. And let me see. I think Justin's holding his thumb up to the
Just as an
screen.
example, in
Yes,
case
but
anyone doesn't
in
have
case-
one of these at home.
In case you want to know where your thumb muscle is, I'm going to put a video on the screen for those of you who are here in the room with us right now, as Justin's holding up his thumb to share. So this muscle is, if you look at your thumb, it is from the base of the lowest joint of your thumb down toward the wrist bone. And the muscle connects, it's one of the fattier muscles that's right in the joint. And it allows the pulling of the thumb into the rest of the hand so that you can touch your thumb to your fingertips. The contraction of that muscle can let you touch your pinky, for example, with the tip of your thumb.
And so
And
This is one of the muscles that swelled up when I got attacked by the Martian. Up to like the size of a grapefruit was right here.
It's probably very sore too. And your dexterity was probably reduced as a result.
Yep. I still drop things constantly
that's
because
right.
of that. Mm-hmm.
So this muscle
I'm
is
guessing it got bigger.
in human. Yes, it got bigger. It got bigger. Yes, it is bigger in humans than it is in chimpanzees. And the researchers compared these existing examples, so chimpanzees to humans, but they also looked at all sorts of other examples of fossilized hominin specimens, also looking and comparing against Australopithecus. Thank you.
Yeah.
Australopithecus, yes. Now, Australopithecus, they have determined, did not have as developed a muscle, this particular muscle, as the other hominin specimens. And they have particular fossils from South Africa that they date back to 2 million years old that they think are the earliest example of the development of this muscle. And they believe that the thumb and that muscle are part of what make humans human.
Ah.
Yes.
So this is fitting the classification that they already had also, right? So
Yes.
this is they already decided this is when the Homo genus started.
Yeah.
And so this is an interesting thing that their classification of these muscles also fits in this same neat category.
The other thing, though, is tool use, because Australopithecus were tool users and creators, but the researchers say that maybe they were just a bit clumsier.
So yeah, I mean, this is the eventual transfer into tool reliant use. I've talked about this on the show before.
Yeah.
That's when you start using those hands a lot more. And once you really are carrying these things around, you're not going to use your hands for locomotion because you got to carry stuff with them. So you got to stay bipedal to carry these things. And then if you're holding on to stuff, it's hard to climb trees because you made this amazing, cool thing. You're not going to put it down. So you just carry it everywhere. You hold on to it, even when you sleep, probably. So yeah, our whole evolution was largely based on our adaptation of stone tools.
Absolutely. And it's really interesting that they are pinpointing it to this particular muscle and the evolution of our dexterity and our hands. But researchers do criticize that there are probably there are 9 muscles or 9 more muscles that are involved in these kinds of dexterous hand movements. And so what about all those other muscles? Just to look at one isn't really enough. So that they're recommending that more of these analyses are done on more muscles.
Yeah, but I mean, they're also not going to, if they're at all interested in this field, they're not going to say like, that's it. No more studies. We've seen enough.
We're done. No more. That's it. We know everything.
Always a need for more. But there's all sorts of stuff that you can look at too, and like the length of the toe bones and the arches and the legs and the bends in the leg. Like there's all of these things are fitting together.
Yep.
In telling the story of human evolution.
Yeah. Anyway, it's a cool story. Takes us back 2 million years to the beginning of the Homo lineage. But let's move on from this into outer space. Justin, what kind of drama is happening on Mars?
Do I have outer space stories? I didn't know that I do. Yeah. So they've got sinkholes. Sinkholes and
watch out where you buy property on Mars.
Yeah, sinkholes and landslides on the surface of Mars. And not a whole lot of great explanation for them. I guess there's been some different theories of maybe this was at one time they were thinking, this was potential evidence for water moving underground. But this is researchers led by the SETI Institute senior research scientist Janice Bishop came up with a hypothesis about what is causing all of this activity on Mars. The team believes that thin layers of ice are melting from interactions between underground water ice and also chlorine salts and some sulfates, which have been creating this strange liquid-like slush moving around. And as it moves from one place to the other, it's creating sinkholes, ground claps, and like different things where we can see landslides or stuff kind of getting upheaved a little bit. One of the things is they'd noticed this previously, that there was, when on the sun, like these things would appear on sun side of mountains and ridgeways and stuff. So this is Bishop again. I'm excited about the prospect of microscale liquid water on Mars in near-surface environments where ice and salts are present. This could revolutionize our perspective on habitability. Just below habitability.
Yeah, you can't
say it. It's a hard word.
Habitability.
Just below the surface on Mars. We were having trouble with all the words and stuff today.
It's not good for people who speak in a podcast.
Yeah, so my
words together.
So some of this comes from previous surveys where they can tell that there's these sulfate conditions in where this is taking place. They believe this is where the ice is. The ice is involved because it's not till it sort of gets heated up by the sun that this effect takes place. My favorite part of this study is that they went and recreated all of these in the lab, which is basically a big bucket of dirt that they put ice at the bottom of and froze, like really froze, because Mars is cold. I don't know if you've noticed, but it's like gets down to negative 60 degrees Celsius.
Frozen.
So they tried to say, what happens if you froze and thawed Mars like soil comprised of chlorine salts and sulfates at low temperatures, such as would be found on Mars. And they got the result of a slushy ice formation near 50 degrees Celsius, followed by a gradual melting of the ice once it got to negative 40 degrees Celsius, which, if you're not familiar with Celsius, negative 40 Celsius is exactly the same as negative 40 Fahrenheit. So it doesn't matter which one you have there.
It's cold.
It's
frozen.
Really cold. But they could tell, like, at that sort of heating up, which is about what happens when the sun hits the open surface of Mars.
And would warm it up. Yeah.
And would warm it up to about that. Yeah, so, and they kind of could, and then they were seeing these effects in their giant mud pies that they had frozen to these extreme temperatures. Yeah, and it was a pretty rapid reaction. So, and also this is, I guess there's some correlations to this that happen elsewhere. One of the researchers had been working, where is it? Somewhere in South America at the dry valleys, these sediments in these dry valleys, where they also have these salt conditions, and they also have these sort of strange implosions and underground slushy things that take place from.
Yeah, I know that that scientists have kind of gone back and forth about these features on the surface, and at a long time ago they were saying, "Oh, these are like mudslides," and then they were going, "Well, how do they get there?" And then they're like, "Oh, these are little rivers and streams," and they were thinking that it might be evidence of actual liquid water on the surface, and then they're like, "Oh no, never mind, let's walk back from that again." And so now they're coming back with this new evidence that it indeed might be this frozen thawing ground and the slipping of it.
They kind of thought before, but it was sort of like Mars would get, like, they thought, this frost layer over it overnight when we couldn't see it, and then the sun would hit it and it would melt so fast, but that would be enough to create some of these effects.
Yeah.
But yeah, it looks like the ice, it's underneath, thin layers near the surface, that mixed with the salt is creating these strange highways of fluidity underneath the soil.
Very cool. Fluidly, let us move from Mars to the moon. Blair.
Very nice. Like the tides go in and out. Let us discuss the full moon and how it makes people crazy.
But it doesn't, does it?
So I brought this mainly because of the very interesting conversation we had last week. So if you haven't heard last week's podcast, now is the plug to go back and listen. Kiki brought a really interesting story about, it was the smallest sample size perhaps I've ever heard on this show, but it was about women's menstrual cycles being affected by the moon, which I took a lot of issues with, but ultimately it kind of brought this whole conversation about how humans are impacted by lunar cycles. And we do know that there is a weird anecdotal thing. If you ask anyone who works in an ER, chances are they'll say, "Oh yeah, full moons, all sorts of wackos end up in the ER on the full moon." So what actually is happening there? And this is maybe a glimpse at a piece of it. So this is from University of Washington, the National University of Quilmes in Argentina, and Yale University. And they were looking at sleep cycles in people and how they oscillate during the 29.5-day lunar cycle. So they looked at these indigenous communities in northern Argentina with little or no electricity. They also looked at college students in Seattle. So they kind of took the electricity thing out of the equation. They removed that variable by checking all of these things against each other. They were consistent. And they saw that there are oscillations of an individual's sleep cycle, regardless of access to electricity. The variations are less pronounced in urban environments, but they're still there. This is essentially, they sleep less and they go to sleep later, closer and closer to the full moon. Depending on the community, the total amount of sleep varied about 46 to 58 minutes, about exactly 46 to 58 minutes. Bedtime seesawed by around 30 minutes. And they had the latest bedtimes and the shortest amount of sleep 3 to 5 days leading up to the full moon. So there's some stuff going on here. Most likely, it is just like we have our own circadian rhythms inside our body. There could be lunar phase rhythms in our body related to the fact that near a full moon, it is brightest. So you can do stuff at night that you couldn't do in other phases of the lunar cycle. So there are advantages, especially if you're a gatherer or if you're a hunter. If you're just trying to gather food of any sort, there is a certain subset of resources that you could get access to in the dusk and then early evening that you could not get if the moon was not out in a pre-electricity world.
Right. Not to mention being able to catch all those crepuscular animals.
Mm-hmm. Exactly. Yeah.
Plus the moon is so loud. It's so noisy. It makes my ears ring whenever it's a full moon.
Just
right? Like everybody else.
If it's not a cloudy night.
Like everybody experiences that, right?
Yes. So what I want to know,
like our ears start ringing. Like, oh.
Yeah.
So what I want to know is whether that effect shifted when it was cloudy and there was no sign of moonlight.
Great question. Yes, that would be an excellent next research question. Their plans for their next research questions are to focus on how the moon is impacting their sleep. So is that an innate circadian clock? Are there other signals that are affecting sleep that are related to the full moon? So, I mean, for example, there are a lot of animals that are louder on the full moon at night. You hear more sounds in general. So is there some weird thing that's just like, the earth is active, I need to be active? They're just,
It sounds like the light has a lot to do with it. I mean, that would be my primary hypothesis. But then
I would agree if we're talking about something that lived outdoors, but we're talking about humans.
Right. And the
cave dwelling thing.
And the difference here between college students in Seattle and people living out in the country in South America, Argentina, it's going to be very different living situations and factors. The other possibility that was brought up in the study last week on menstrual cycles is that there's also potentially an impact of the gravitational effects of the moon. Which I think would be harder to prove.
Yes,
but
definitely,
yeah. I don't know.
Yeah, so as opposed to the situation with the menstrual cycle, which is it's about 28 days, and a lunar cycle is about 29 and a half days. So also just maybe that's just coincidence.
And over time, and over time you will overlap.
Yeah,
it's gonna happen. Yeah,
but this is less easily explained away, I think, and it's an interesting question of, yes, we live inside, yes, we have electricity, but that's only been for about 200 years, and as we just discussed, we've been humans or a hominid of some sort for about 2 million. So that's a lot of history of living with the moon that we could potentially be working with. It's very early for us to be ditching those evolutionary habits. So,
and I do know that just anecdotally, I have to pull my shades down. Must pull the shades down when it's a full moon or around it because it's so bright.
It is disorienting.
It's too bright.
Yeah, and even if you're out and about, you feel it. You're like, is it nighttime? It's too bright out here.
No, it's because it's making that sound.
It's making this.
It's making that sound. It's so loud.
So it sounds like Justin can hear light. So
I can hear the moon. I mean this.
It's moon synesthesia.
It's just like a really fast ringing bell. You don't
that's
hear
your tinnitus.
Oh yeah. Well, that's what it is. It calls it. Yeah. It causes the tinnitus.
So it kind of sounds like Justin needs to be the focus of a story coming up. But in the meantime,
In the meantime, let's talk about wind.
yeah.
I got some wind for you all. Wouldn't it be great if wind and solar could make up more of our sustainable energy supply?
Yes.
It would be great, right? But shouldn't we know where to put the windmills?
Benicia.
And but Benicia isn't the only spot. But it's a great
Benicia can
example.
take care of a lot of it. They have trees that grow sideways there.
So expand on that, Justin. What is the wind like in Benicia?
It's goes in the same direction because all the trees it comes through. It's strong and it's consistent.
It's consistent and it's extreme. And from my sailor family, this one, Dad, I learned from you. It blows like snot. Anyway, the wind is very extreme. And so you need to know the extent of the wind speed. How extreme is it going to get in any particular location? You have to know how big a windmill you can construct. You have to know how strong that windmill needs to be. You need to have all sorts of engineering factors taken into consideration. And if you don't know the wind that you're going to be up against over the lifetime of a windmill, you could be overstressing that windmill, causing it to break too often. It could lead to all sorts of unintended costs. Or you're going to be putting something too big in a location where there's not much wind and you just need a lightweight windmill to get things going. So it's really good to have some kind of an atlas where wind speed is specifically mapped to location, and publishing in Nature Energy, a bunch of wind energy scientists from Cornell University have released a new global wind atlas. It's an atlas that documents extreme wind speeds for the whole world, lots of different locations, so that people who want to build windmills and don't know where to put them, they can look at the atlas and say, hey, that's a windy spot. Maybe we should think about that spot. And it will direct people a lot better in their sustainability efforts.
That's very cool. I also love the idea of saying, hi, nice to meet you. What do you do for a living? I'm a wind scientist.
Wind scientist.
Oh my gosh, that's amazing.
My science blows.
Oh man.
Don't get them started on turbulence, though.
No,
they will not be quiet again after that.
So I have this thing stuck in my head forever. That there was, I think it was a high schooler who won some big prize in a science contest for submitting a design for a windmill that went over freeways. So it was one of those ones that's shaped kind of like this with the blades, and
it's shaped horizontally.
Yeah, and because freeways are consistent wind, right? It's there's it's always going in the same direction, because all the cars speeding by create this wind. It was this idea. It was exactly the same. It was a consistent movement of wind at a fairly consistent speed.
And if cars are going to be producing this turbulence and this movement, then why not?
Yeah.
That's great. Yeah. So according to the paper, the total global wind turbine installed capacity is more than 651 gigawatts. Wind is now generating over 1,700 terawatt hours of electricity per year. This is only 7.5% of global supply. In addition, the United States...
it's got how much?
7.5% of the global supply.
Wow, that's incredible.
It is incredible, but we can do better. We can do more. United States, our power is carried by 17%. It's 17% wind installed capacity. Europe, 31%. China, 36%. Yeah. The installed capacity for wind energy of the total. we're getting there, but we need to make more efforts like this to make it better and easier. All right, Justin, tell me about some old symbols. Is that what you want to talk about?
Yeah.
Or did you have another idea?
No, this is a good one. Discovery by archaeologists from the Hebrew University and the University of Haifa, and a team led by the Le Centre National de la Recherche Scientifique, which I believe is in France.
Mm-hmm. That's a good guess.
Have uncovered evidence of what may be the earliest known use of symbols. This is not like drumming, though. This is like written.
Oh, okay.
Bump.
Although the oldest known symbols are made out of giant rock slabs that can be played. They're insane. But no, this is those are much more recent. Maybe 10,000 years old. I don't know. Symbols were found cut into bone fragments from the Ramel region in central Israel and are believed to be approximately 120,000 years old.
Oh, wow.
Mm-hmm.
Amazing.
Remarkably, the fragments remained largely intact, and the researchers were able to detect 6 similar etchings on one side of the bone, leading them to believe that they were in possession of something which held symbolic or spiritual significance. The find, which is published, was a Quaternary International, was discovered in a trove of flint tools and animal bones exposed at the site of during an archaeological excavation. So they think this was a Paleolithic hunter camp, meeting place, hangout spot where they'd like get together, slaughter animals, talk about where they'd seen other animals going, maybe. Bone is believed to have come from an extinct wild cattle that was very common in the Middle East at that time, but now no longer exists. So they did some 3D imaging, they did some microscopic methods of analysis, and they reproduced these engravings in laboratory. And they got 6 different engravings, which, if you look at it, is basically like 6 almost straight parallel lines to each other. Sort of looks like primitive doodling, but Dr. Iris Gorman Yaroslavsky of the University of Haifa explained, based on our laboratory analysis and discovery of microscopic elements, we are able to surmise that the people of the prehistoric times used a sharp tool fashioned from flint rock to make these engravings. Paper's authors stress that their analysis makes it very clear that engravings were definitely intentionally man-made, could not have been made by animal butchering activities. They also look at, they were able to determine that this was performed by somebody who was right-handed, and that it was done in a single working session. So this is done all at one time.
It also looks like they went from right to left. I don't know why I think that, but that is kind of how it looks. And that's also how Hebrew's written. Right to left.
That's interesting.
So, I don't know. It's a coincidence, I'm sure. That's 100,000 years. But it really does look like it's kind of slanting towards the left.
But in terms of what it looks like somebody was trying to put lines, vertical lines.
However, if you take it and you turn it upside down, the image that you're seeing,
it looks
then they would be going the other way.
Yeah, that's true. That's fair.
So I'm not really sure.
Yeah, they don't know which. Well, so that's an interesting point. So how do they know it was someone who is right-handed then? Because you could just turn it upside down.
Yeah, they also make the inference that it could be symbolic or spiritual, which is also a lot of inferencing going on for a couple of parallel lines on a piece of bone.
Yeah, it could just be somebody scratched parallel lines in a piece of bone because they were bored.
Yeah, it could have just been.
It also could be like them counting
inadvertent doodling.
Right? Like that was the other
counting.
thing I was thinking is they could be doing a ledger.
Yeah, they were keeping score of their pinochle game. I don't know.
Yeah.
This is Marian Prevost from the Institute Archaeology at Hebrew University says that Every indication was that this was a definite message behind. There was a definite message behind what was being carved into the bone. We reject any assumption that these grooves were some sort of inadvertent doodling. That type of artwork wouldn't have seen this level of attention to detail, which is kind of like, there's not a lot of detail there. But the idea that there was a doodle form of this is what she's almost, her assumption is that for this to have been Paleolithic doodling, it would have been much simpler.
All right,
Simpler than lines.
I feel like we're sitting here, we're picking this apart, but also keep in mind that like somebody gets a toe bone from a dinosaur and is like, it looked like this. So it's, you know, they're extremely well educated guesses. We don't understand the entire depth of research and knowledge, and
we don't. I'm also gonna say though that it could also. I mean, it's an inflated sense of self-importance and an inflated sense of the research meaning something, and it could be. I mean, but you are absolutely right. The people who wrote this paper know much, much more about this than we do. So yes,
I'm just throwing it out there. I agree. It's like a lot. It sounds like a lot from a little thing with some scratches on it, but. Just I'm throwing out there. There's a whole background of research that we're not privy to. So it's
maybe the other bones in the pile had the significance of all the bones and other leftovers.
Yeah.
Maybe that tells a bigger story.
Yeah, it can. I mean, I'll buy that this may be one of the earliest forms of a carving on bone intentionally that we've seen. For you to get into to say this is symbolic, right? Like this is meaning, then we need more context. I need a call and response. I need it, not just a deciphering, because like cuneiform looks like nonsense to me to this day. But the Sumerians had a language, and it was mostly like, you know, who owed who how many bushels of wheat or whatever. And it was like day to day. Like they literally had like iPhone size tablets that they were writing on most of the time. And these things are discarded. Like they found tons of this. We know it's writing. This is carving on a bone, which you're doing already when you are. Yes, this is different than butchering the animal. But you're already there. You might be like, hey, is this a good knife blade? You know what? I kind of think this one is. Yeah, this is pretty good. Look how it cuts into this. Like
Or you have a job within your tribe of people that's really boring, and you're biding your time watching the deer or the sheep, you know, whatever it was.
I'm more interested to find out who the people were who were doing the carving.
Yes.
Than it is really what Anyway.
Yeah, I like it. That's a good story. Takes it into a deeper human meaning. Okay, you know what the biggest human deep thing is that first sip of coffee in the morning.
Oh, yeah, that's a good one.
It's a good morning coffee. It's amazing. And we keep talking about how climate change is going to be threatening a bunch of coffee plants, and there are fungal species that are attacking the coffee plants. There's one particular fungus called coffee rust, which is threatening Arabica beans particularly. But there are funguses like this that threaten these plants and these plantations and the crop of coffee. We must have the coffee. So researchers have been trying to figure out ways to address the coffee rust problem. And one group found another fungus that seems to have, they think, potentially an evolutionary relationship with the coffee rust fungus, and that they control each other. So the researchers are looking at this fungus in Ethiopia as a potential solution to the coffee leaf rust problem. They don't know for sure yet, but they are definitely going to investigate it a bit more. What they found is that coffee leaf rust generally increases during the rainy to the dry season. And then there's this hyperparasite, they're calling it the hyperparasite, that lives on top of the coffee rust fungus. And as the coffee rust fungus gets eaten away, the hyperparasite increases from the dry to the rainy season. So they kind of balance each other over the seasons. And it seems to be a stable relationship in Ethiopia. And in plantations in Ethiopia where the Arabica beans were very managed, they had more problems with coffee rust than unmanaged, more naturally fostered crops that allow the hyperparasite to grow. And so the next question is, does it have any impact on the actual output of beans from the plants? They don't know this yet, and so that's what they need to look at. But biocontrol is a potential direction for these crops that we have taken out of their native growing environments and moved around the world to different places. Those parasites, the funguses, might come with them and spread as well. But how do you take up some kind of biocontrol as opposed to bringing pesticides to keep the fungus at bay?
Will it make my coffee taste like mushrooms?
No.
Okay.
And the researchers actually say that they think that this is an evolved relationship between the coffee plant, the coffee leaf rust, and the hyperparasite.
That's very interesting.
Yeah. They do better together.
Huh. I wonder, so coffee as a monoculture crop is kind of problematic. And there's a movement to do a I forget what it's called, but it's when you grow multiple crops on one piece of land and they kind of work with each other. Just like vanilla needs a little bit of shade, coffee actually does well with some shade also. So you can do different height plants in the same plot of land and farm multiple things at once. So I would wonder if we were trying to move that way with coffee anyway, since the monoculture is so problematic, would this fungus relationship potentially mess with that actually? And if you tried to grow other crops in that same space, would that be a problem?
I don't know. Yeah. Would this fungus interact with other plants? That's a big question. It does seem to do better. So the coffee plants and the hyperfungus like being in the shade of the trees. So like you're talking about these multi-layered plantations, that's something that they are thinking is definitely a good direction to go. Mm-hmm. But yeah, I mean, biocontrol, you always have to think about the other things that your biological control could affect.
Yeah. Well, because that's my problem. I depend on coffee so much, and I love coffee so much.
Okay. Stop. This is right. Okay, no, this is the problem. There would never be a threat to coffee supply. You could get the good stuff really
if we didn't
cheap.
like
if
coffee?
you stop telling it, if we just stopped, all coffee drinkers kept telling everybody how great coffee is. Just pretend it sucks. Coffee, it's like this terrible, awful thing. Kids, you don't want. If the next generation drinks coffee like we drink coffee, we're gonna be out of coffee. That's just all it's gonna come down to. We're
Does that work so well with fossil fuels?
We're just not, there's not enough of it. Wait, what?
If we drink enough coffee, we're going to run everywhere.
It's a finite resource, people.
It is.
There's only so many coffee beans the planet can support. And I think we're using all of them right now.
I know not everyone drinks coffee. And good for you if you don't drink coffee. That's great. That's good.
Because it's terrible stuff. You don't get started. It's just nasty. Ugh.
More for us.
This is This Week in Science. Thank you so much for joining us this evening. If you are interested in some item of our merchandise, head over to TWIS.org and click on the Zazzle store link. You could be like Justin and wear a TWIS sweatshirt. He's got a TWIS sweatshirt on tonight. A pretty great, cool sweatshirt with some of Blair's art on the back. That's right, Zazzle store, TWIS.org can help support TWIS. All right, let's come on back for the fantastic COVID update.
Is it
Stay up
fantastic?
late because we can't sleep because we've got so much anxiety. The COVID update. I just made that up. Okay.
Accurate.
Accurate. It's true. There is some very interesting research highlighted by the CDC this week, which I just really enjoyed. One particular study out of that is published in Science Advances this week that the CDC highlighted, which is titled Airflows Inside Passenger Cars and Implications for Airborne Disease Transmission. So if you like to hop in an Uber or a Lyft and ride share with other people, this study is for you. Looking at airflow in cars, they found that when driving at 50 miles an hour, having the front right and the rear left windows open, so across the car, this isn't in a single cab truck, this is a vehicle with front seats, back seats, the front right window open, back left, rear left window open, driver sitting in the front right, passenger in front, driver in the front left, passenger in the rear right. The airflow was pulled in through the rear window and circulated around the car in such a way as to create what they called an air curtain that would protect the passenger from any germs that the driver might have.
Yeah, so because it's coming in the front passenger seat and exiting the rear window, right?
But that's it. Not so much. The way that the airflow actually works is because of the way that the air gets sucked into the car. Most of the air is entering through the rear window, circulating around, and then getting pulled back from the front window past the driver to the back to the rear window again. It's a very interesting airflow pattern that I actually did not expect. So the dynamics of it are really interesting.
Weird.
Yeah, they did not test this at lower speeds. They didn't test it with, more make-believe passengers who could be infected. They didn't test it with a whole bunch of variables. But if you're a single passenger in your rideshare vehicle, or if you're going to go pick somebody up, know that you can help increase your safety with a very simple opposite kind of kitty corner open windows and seating situation. Yeah. It's
interesting.
Very interesting. Very interesting stuff. And also in this particular highlight from the CDC were a couple of studies that imply children under 20 years of age are less likely to show symptoms, be symptomatic with SARS-CoV-2 infection, and are also highly likely to spread the SARS-CoV-2 virus, more likely than had before been expected. And as we are talking about trying to get kids back to school, and with these more highly contagious variants on the rise, maybe this is information that school districts and governors of states should be taking into account. So,
get those teachers vaccinated, please.
Yeah, get the teachers vaccinated and get the grandparents vaccinated, and just let's not put the kids back. No, don't do the 6 weeks thing. We've already talked about that. And you just jumped in here. It
wasn't even what I was going to say.
Okay.
But this is more proof that we need to reverse the order of the vaccines. Give it to the young. If you want to open schools, then vaccinate the children. If you want the college kids back on campus, vaccinate them first. But
no, because we don't. The thing is, we don't. So right now we are working from the knowledge that the vaccine protects the person who's vaccinated, but we don't know whether vaccinated people can still spread infection.
still not know that. How can
So
we
they
possibly not know
basically
that?
they didn't test that when they were testing the efficacy of the vaccine because they were trying to get it out. So that was something that they did not. So now they're trying to collect data on that currently while they're vaccinating people.
Yeah.
Because it was more important to get it passed so that people who are constantly actually exposed could be protected.
Yeah, well, I guess what I'm getting at is this is not a study that can be done in the United States. I absolutely agree because we have no testing
We have uncontrolled
available.
spread also.
We have uncontrolled spread and we have no testing. But in scenarios of places that still are able to test and contact trace, that's what that needs to get figured out there because it's ridiculous that we don't know it and yet there's millions of people infected.
Yeah, it just makes it makes the whole situation more complicated. But we are currently vaccinating more people each day than are being infected globally.
Yes.
This is great news. Okay. There's also I have a couple of little brief bad news stories for you. And then I've got good news, okay? I want to end the COVID update on good news. But first, let's talk about these new variants. There are a bunch of them circulating, increasing numbers because, hey, they're more easily transmissible. They love grabbing onto that ACE2 receptor nice and strong, helps them get access to the cells more easily. So fewer viral particles are necessary for an infection. Anyway, a preprint in bioRxiv suggests that the mRNA vaccines in use are still effective against these mutants. These are new mutations that are making the transmissibility more effective, but they're also starting to evade our defenses a little bit. And so even though these mRNA vaccines are still effective, there is a reduction in their effectiveness when they've been tested in laboratory situations. Sometimes up to a 10-fold reduction in their effectiveness, which would mean that we definitely need as many people vaccinated as possible, as quickly as possible.
Well, I think they even said at one point that between even like some people said 60 and some people said 80% efficacy would still be effective at reopening the country if everybody got it.
90.
So higher is better, but I remember there were people saying like if the vaccine is 60% effective, push it anyway.
Yeah. Absolutely.
Oh, no,
and they are.
100%.
Which is another aspect of the Johnson & Johnson vaccine, the Oxford AstraZeneca. They are that is less effective after the first shot, and it is in the 60% to 70% effectiveness range, but it seems to become more effective over time, that the body's immune response improves within the weeks after having gotten the vaccine. And so they're thinking that this single shot with a lower effectiveness, it's still effective, but it's going to help reduce transmission, which that's what we want. Anyway, in the treatment side of things, we have been using some of these monoclonal antibody treatments, which are basically antibodies that go in and neutralize the spike protein and make it unable to attach to our cells to gain entry. Another study looked at a particular mutation, that's the N439K mutation, found that the monoclonal antibody treatments are less effective against the variants that have this change. So not only are these variants starting to evade our defenses, but they're also starting to evade these antibodies and this particular kind of treatment. So the monoclonal antibodies, that's the remdesivir, the treatment that people with money are getting. Not everybody's been able to get. So we'll see how long that remains viable as a treatment and a good treatment. Good news. Good news. There have been questions about whether people who are pregnant should get vaccinated. The decision was made to allow pregnant people to get vaccinated And there is now evidence from a study out in JAMA that not from vaccines, but from COVID infections, that there is evidence of antibodies, immunoglobulins produced as a result of the infection during the mother's body's fighting the virus, that they're finding those immunoglobulins in the cord blood. The fact that they're in the cord blood in the placenta means that these antibodies are very likely to be getting to the fetus. And so if they're getting to the fetus, that means that the mother is passing the immunity along to the baby, which is great. Yes. So other vaccines, they've seen very similar effects. And so they believe that vaccines of pregnant women could confer immunity to the babies. So that's good news. Very good news. And finally, let's get happy. Some happy treatment. There is a study out this week suggesting that an antidepressant, an SSRI, called fluvoxamine, might help treat COVID-19. We've reported on this before, and there have been a couple of studies previously, but this new one was a trial that took place in California at the Oakland race. Was it the Berkeley racetrack? The Berkeley racetrack in the San Francisco Bay Area. And it is, most of the employees are Hispanic. Right around Thanksgiving, when there was a huge spike in infections, they had a big outbreak of COVID-19. There was a doctor who had applied for money from a private fund that is funding projects to see if drugs that have already been authorized for use for different uses by the FDA could also be used to treat COVID-19. Got some of that money, randomized the groups, like half of about 60% of the people had COVID and wanted to get this treatment. 40% didn't. What they found, there were no hospitalizations in the group that got the 2-week course of the SSRI. And in the placebo group, there were multiple hospitalizations and 2 ventilations and I believe 1 or 2 deaths that were correlated. So it's not a randomized control trial, but it is another piece of evidence suggesting that this SSRI, which also acts on a very specific receptor, a sigma receptor, to reduce the body's immune response, could be helpful for treatments moving forward. Yeah. So it's not at the point of, hey, everybody, this is what you need right now. But doctors are starting to go, oh, well, if I have a really, really, like a patient who's really on the ropes and looking bad, maybe this is something that we could try. So it's starting to hit that point. Happy news. More treatments, possibly. Research is moving along. We are getting there. There's hope.
Life could get back to normal by 2022, perhaps.
Ish. Yeah.
That's right. Okay. This COVID update, unless there is something really, really big that happens over the next couple of weeks, what I'm going to try is a new strategy for the show where we will do a COVID update at the beginning of the month, and we'll alternate weeks.
Have we got COVID? Have we got COVID fatigue? Have we got COVID reporting?
I think everybody's trying to make my TWIS prediction come true right away.
Right away. I'm also going to try and split it up with interviews so that we have at least 2 interviews a month. And awesome. We have a reduced number of COVID updates, but really try and give you good news, give you the news when we do the COVID update. Just so you know. This is This Week in Science. Hey, you know what time it is?
What time is it?
I think it's time for Blair's Animal Corner.
With Blair?
She loves our creature, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. An animal corner.
got, Blair?
Well, I have a story about singing crickets and how traffic noise could be messing their mating strategy up. So this is from Anglia Ruskin University. And look, it's looking at the mating behavior of crickets, famously known for singing. And it looks like their mating behavior is affected by traffic noise and other man-made sounds. This, of course, has implications on other animals and crickets worldwide. But so they were studying the mating choices of female field crickets, that's Gryllus bimaculatus, under different acoustic conditions. They paired female crickets with silenced male crickets. Was that a cricket? They paired them with silenced male crickets. That's important so that they could then play cricket sounds to control for the individual. So they had these silenced male crickets, and then they would pipe in ambient noise, artificial white noise, and traffic noise. So they had these kind of different levels of competing sounds with cricket song. And then they would play cricket songs of varying quality. This is important because the females are already choosing males based on the quality of their song. So they have to make sure that they're not crossing their wires here, that they're playing, that a cricket has a bad song and there's traffic noise. That could be confounding variables, right? So instead, they're all silent. They're playing different quality of cricket song as far as female crickets are concerned. And then they have these different noises in the background. So in control conditions of ambient noise, females mounted the males much sooner and more frequently when they had a high quality courtship song. So normal, wild sounds, so low, not really intrusive. And then, oh, that's a good mating song? Great, I'm ready. Okay, however, high quality songs had no benefit versus low quality songs in white noise or traffic noise conditions. So the females are not doing a good job of picking out the good cricket songs when there are these other sounds happening in the background of the white noise or traffic noise. So they were not influenced by the presence of song at all. There's a little cricket. Is that a high quality cricket song or a low quality cricket song? You decide. I don't know.
I have no idea.
Yeah. So the bottom line here is that man-made noise, this white noise or traffic noise, which, by the way, they got the traffic noise by actually putting these containers of crickets next to a freeway, which I thought was great. No better
ambient noise, the freeway,
yeah.
Yes.
So the man-made noise does alter how females perceive males when making mate choice decisions. So there's a couple ways that this could impact the future generations of crickets and other animals who have sexual signals that are auditory around man-made sounds. So the first would be that, actually, the researcher said, I didn't even think about it, is that the male crickets might actually try to expend even more energy to make even better songs because they're not getting an edge on other crickets. But what I see here is the likelihood that there would be a reduction or loss of good quality cricket sounds in general. Everyone would just become kind of lousy at singing. But there's also an expectation that the quality of the cricket song is somehow linked to fitness. So the other problem here, the really big problem, is not just like, oh man, we might not hear crickets anymore. It might actually lead to a reduction in offspring viability because a good song is supposed to be linked to fitness. So if you are not selecting for a good song, you are no longer selecting for fitness, that could have huge problems on the fitness of crickets. So, I mean, the long and short of this is like, hey, humans make a lot of unnatural sounds. It's messing with animals that talk to each other. We knew that already. We've done
Yeah.
stories about bird song and all this kind of stuff, but it's interesting to hear it about invertebrates also, and to kind of see this very specific delineation where even white noise, just unnatural white noise, was also causing problems, not just traffic sounds.
Just anything that is increasing the volume of the environment and making it harder for other sounds to propagate. I mean, white noise is great at blocking other noise. So, I mean, so many people have white noise generators or pink noise generators to help them sleep because
what
they
is
live in a
pink
noisy
noise?
It's different frequencies, but yeah.
Oh, I didn't even know about that.
Yeah, and the only reason that people use those things is because they can't sleep with all the sounds of those crickets outside. It's just, God!
All right, well, anyway, crickets. And moving on from fitness of crickets to fitness of some other animals, this is an extremely preliminary, just kind of a look at animals and specific strategies for getting help from relatives in raising their young. This is some biologists from University of Bristol have a new argument that they want to explore, that some animals might use blackmail to coerce relatives into assisting with the rearing of young. So, yes. So in the historical way that we've looked at family members helping with the raising of young, this is the Darwinian hypothesis that family members help because there are shared genes. And so they help because the cost-benefit analysis shows, this is also called Hamilton's rule, actually, so it wasn't Darwin. They will help if it leads to a net increase in copies of your genes in a population. So if I help my brother raise his kids, then my genes will benefit because there are some of my genes in those kids. So is the cost-benefit analysis beneficial to me? But this new exploration is looking at manipulation wherein an individual can threaten to harm their own survival or their own reproductive success if relatives withhold help.
Oh, it's emotional blackmail. Now it makes sense.
Yes.
Now it seems normal.
It is. I'm so mad at you. I'm going to hold my breath. I'm going to pass out. I'm going to really do it.
And it's your fault that I'm doing it.
Yes.
That emotional blackmail sounds like human families.
Yes. So an example that they saw in the wild is that a mother wasp may lay a large clutch and all but exhaust her energy reserves, laying so many eggs. So unless a relative steps in to help, the babies may not survive. Neither may the mother. So it's kind of like, oh, whoopsie, guess you'll have to help now. You have no choice.
And this is how social species begin.
Yeah. So it's about putting shared genes in jeopardy. They also like to think about this in terms of a doomsday device. So if you think about how a doomsday device works in kind of modern culture, it's a mechanism that will trigger a disastrous nuclear strike if a rival makes an unwelcome move, right? So this is part of what the Cold War was about, was like, you might nuke us, but I'm going to nuke you then, and then we're all going to be nuked. So it's like, if animals can tie their own survival or reproductive success to a partner's behavior, then the threat of self-sabotage becomes credible. So this preliminary paper looked at whether blackmail between kin is theoretically possible, and they did a bunch of mathematical science. They looked at it, and it is viable. Under the right conditions, it can evolve and be selected for in these social species. So under this illusion of harmonious cooperation among relatives, some animals might have been given no choice. So hopefully we'll get
No
more on
choice.
that in the coming years. I would say I'd love to see a paper actually detailing this in a specific species, or looking at some of the pro-con kind of data that we might have about how well this works. But it is a very interesting look at something where we'd love to think about animals as like, oh yeah, they love to help each other. Like that's why we have grandmas, right? Is so that they can help with the fitness of their genes that are in their grandchildren. And it's just a big happy family. And
But maybe
not.
they were blackmailed into it and grandma really wanted to go have her own life.
And they were like, okay, you can do that.
But I think isn't that the same? I mean, then that's the same motivation, though.
It's
you have to help because you want your genes to prosper and continue, even though you that's how you're getting emotionally blackmailed.
Well, it's like the adult child that lives in the basement. Like you really like them to go live on their own, but you're not going to put them out on the street, right? So I think you're right. It's the same net result as you're trying to protect your genes.
Yeah.
But it's just the reasoning behind it is different.
The urgency.
The motivation.
The motivation, I think, is the same. The urgency.
Well, no, the motivation is different because it's a threat versus a want to help with a general success.
I think it's the same. It's just both times
It's not, because if you think about like true altruism is you're trying to, and that's separate from this. This is not altruistic behavior because you're benefiting, because your genes are benefiting. But if you think about altruism, it's different from symbiosis because one is you're helping another being and you're getting nothing in return. And another one is you're helping another being because you're getting something in return. So there are different motivations for different strategies in the animal kingdom. And those small differences matter.
Okay, I still don't believe in that definition of altruism, but that's I think there is still a selfish motivation behind that, which is being part of a herd or a community, which is that's your duty. That's the expected, that you're going to be helpful and compliant to others when they need it, because that's what you get also out of being part of that community.
So are you returning the wallet you found on the street in the hopes that someone else would do the same for you? Or are you returning that wallet that you found on the street because you want $50 as a reward? That is the difference.
I don't see it. Oh, well, okay, that's no, I think it's the same. Then everybody's always doing it because they're going to get their wallet back, or it's going back to their community.
That's the idea of reciprocity.
Yes, so there's differences there. There's a difference in an expectation of mutual response and respect and a reward. Those are different things.
I disagree. I think both of them have that same reward. I think they do. I think they absolutely do have a selfish motivation behind both of them.
I never said it wasn't selfish. I said the reward was different and the motivation was different.
The reward's different.
Yeah. So there's an interesting article about this right now in Nature in the news.
Wow, people are quick. We just had a conversation. Somebody's already done a paper on it.
Yeah, there's a paper out now on the evolution of altruism and the serial rediscovery of the role of relatedness. Like, seriously, this conversation right now. And they talk about Hamilton's rule in the 1960s. The evolutionary biologist W.D. Hamilton came up with a solution to the problem of altruism. So how did it evolve, and could it have evolved without relatedness being a part of it? But anyway, there's a whole paper on it. I haven't read it, but from what I can tell from skimming, it concludes that relatedness is pretty much it. That's what starts altruism out. There's a role for relatedness for altruism to evolve. The genes. You got to be in it for your genes at some point. but the motivation makes a big difference. What is that motivation?
Mm-hmm.
This is This Week in Science. We are here again to talk with you about all the science things that we loved this week. Thank you for listening. If you are listening and enjoying the show, maybe consider supporting the show. We do take donations through PayPal and also through the Patreon platform. You can click on the Patreon link at twist.org, head over to Patreon and choose your level of support. Those over $10 per month get thanked by name at the end of the show. Your name could be read in the list. Help us make that list longer. We can't do this without your support. We thank you for your support. Alrighty, Justin, do you have some news for us?
Yeah, I don't know what particular order I got it in, but this is anthropologists from the University of Zurich. They want to know what monkeys were thinking about when other monkeys were talking. So they shot them in the face.
Wait, what?
With non-invasive thermal imaging guns, able to measure temperature changes in the faces of the marmoset monkeys to quantify subtle emotional responses that they were having. So monkeys experience an increase in emotional arousal. They will then show a drop in facial surface temperature, especially on the nose, because it's not covered. Says first author Rahel Brugger, PhD candidate, Department of Anthropology, University of Zurich. We were able to use this technique to show that the marmosets did not perceive the vocal interactions between conspecifics as the mere sum of the single call elements, but rather perceived them holistically as a conversation. So basically, two monkeys are talking. Instead of just that monkey reacting to each single call separately, was reacting to the conversation that was taking place between these other monkeys. For their study, these researchers used playbacks of vocal exchanges between marmosets, as well as calls of individual animals who were not involved in an interaction. They played the corresponding playbacks from a hidden loudspeaker, used the thermography to measure the monkey's reactions to the various simulations. This showed that the responses to the individual, to the call interactions was significantly different than the responses of just individual calls. So they could tell the difference between a conversation and monkey monologues. In the simulations, the researchers additionally distinguished between cooperative and competitive interactions. After the monkeys had heard different interactions, they were then given an opportunity to go closer to the sounds that they were hearing from the separate speakers that they had playing back and forth. The researchers observed the marmosets preferred to approach the simulated monkey sounds in the conversation who had been involved in a cooperative interaction with the third party. That preference actually fits the social system and natural behavior of these small Brazilian New World monkeys who are cooperative breeders and depend on the cooperativeness of others in their group. This is Judith Burkhardt, also anthropologist. This study adds to the growing evidence that many animals are not only passive observers of third-party interactions, but that they also interpret them. In addition, our study shows that thermography can help unveil how these social interactions are perceived in non-verbal subjects.
I feel like if you couldn't read the room, read the treetops,
Yeah.
as a social animal, that would be a big mistake. That would mean death a lot of the time, I feel like.
Yeah, and especially with animals that are social in nature, you want to be able to understand what your conspecifics are talking about. Or, okay, are you just shouting at the sky? Or are you talking about a predator? Or have you found a food source? They're a cute little marmoset that you got your eye on. I don't know. What are you talking about? And you also want to be able to, as we've talked about in the Animal Corner so many times, be able to read the other animals in the local environment. What are they doing? What signals are they giving off? So this is, but I like the thermography as a way of being able to read the emotional state. So how excited or interested based on blood flow. That's a very interesting perspective.
Yeah, it's a nice way of being able to monitor the monkey without having drilled holes into the skull or
right. What are you paying attention to, monkey?
Yeah. Non-invasive. You get a little bit better natural feel for behavior that way.
Yeah.
Yeah. It's a neat setup. Although, I mean, externally, I guess we people who study marmosets probably have a good idea of what physical behaviors mean, whether certain facial, like putting your face in a particular way is aggressive or not aggressive, or excited or not aggressive, holding your body in a particular way, what that means. Yeah.
Yeah. If you can use AI to interpret the position of horses' ears to figure out how they're feeling about a situation,
yes,
I feel like you could definitely do the same with monkey faces. It would be very cool to do both together.
Yes.
Is some sort of AI looking at monkey faces, the expressions that they're making, coupled with
I like that. Yeah.
the heat distribution in their face.
Yeah, and why this is also important is that even though the researchers might be able to look at the little monkey and say, "Oh, I can tell how the monkey is doing right now," or what the monkey, that's not science. You can't translate that into a paper. You can't say, "Well, how do you know the horse is hungry?" Well, I could just tell by looking at the horse.
Yeah.
Then you're just a horse whisperer. You're not doing science, right? You need to be able to get
have
away
a measure.
You need a measure that doesn't have human observation as its sole.
That's a great point.
Yeah.
Yep.
Yeah, and there's definitely the indescribable thing. I mean, when I was a zookeeper all the time, there were times where I would go to the zoo vets and be like, so and so, there's something wrong with them.
Yeah.
And they would say, well, why do you think that?
I just know.
Got a hunch.
I got a hunch.
There's something wrong with them. I don't know. And, eventually we were able to figure out they were eating less. This was happening. That was happening. They would get taken in to the vet and they'd figure out what's going on. But there was this weird kind of aura of, there's something weird there. So yes, there's something that
you're making observations that you haven't translated into specifics. Correct. and it's still triggering the proper
gestalt
response.
response.
Yeah. I mean, yes. I did an emotional intelligence training for my job earlier today, and they did a quiz where they showed people's faces and you had to say what expression it meant, which actually sounds a lot easier than it is for the average person. I mean, some of them are really easy, but some of them are harder. And they actually pointed out what about that person's face indicates that they're happy or sad or shy or embarrassed or in pain. So they pick out these little things. And that's exactly it. There's stuff going on that you notice that you can't quantify. And you just go, that person's mad.
I know that. Yeah. Fascinating. You got another story, Justin?
Sure. This is the freshwater oceans of the not so distant past. The Arctic Ocean, the one up in the top there, was covered by 0.9 kilometers of ice at one point, or 900 meters, if you're not familiar with kilometers, was entirely filled underneath with fresh water twice in the last 150,000 years. This was reported in the latest issue of the journal Nature, result of a long-term research by scientist Alfred Wegener at the Institute of Marham. So basically what they've done is a detailed analysis of the composition of marine deposits that could demonstrate that the Arctic Ocean, as well as the Nordic seas, that below Norway and Sweden and north of Germany and Denmark, did not contain sea salt in that water. And at least two glacial periods in the last 150,000 years. kind of seems, I mean, it makes sense once you picture the glacier there, that it's only fresh water that's going into these areas that are evacuated, right? Or these lower elevation places where seas are currently. But it's really weird to think of that much fresh water in those places. Detailed analysis illustrates this. The water then also was occasionally released into the North Atlantic in very short time periods, with sort of, you'd end up with this freshwater underground lake, or a freshwater at ground level lake, with a kilometer of ice on top of it, could then shoot out in really short periods into the North Atlantic, thereby cooling the North Atlantic, messing up the Atlantic conveyor belt, and they think has been responsible for a couple of the rapid climate oscillations that they've seen in those regions that they didn't really have any good explanation for.
Oh.
So about 60 to 70,000 years ago, a particularly cold part of the last glacial period, large parts of northern Europe, North America were covered by ice sheets. European ice sheet spanned a distance of more than 5,000 kilometers from Ireland and Scotland via Scandinavia to the eastern rim of the Kara Sea, which I don't really know where that is, somewhere. North America, large parts of what is now known as Canada, I don't know if I'm reading that right, were buried under two large ice sheets. Greenland and parts of the Bering Sea coastline were also glaciated. It was just a big old iceberg up top. But yeah, there was two different periods though. Once about 70 to 60,000 years ago, 130 to 150,000 years ago. Both periods, freshwater accumulated under the ice so much that it created a completely freshwater Arctic Ocean for thousands and thousands of years.
Is it really? Is it just a big Arctic lake at that point?
Yeah,
big frozen lake.
Shaped like a kidney bean, looks like.
Yes. That's what the model makes it look like in this image. Yeah.
Huh.
Yeah. How fascinating that it would get penned in on so many sides by the underwater topography and also by the ice, and push out all the salt to the point that you have that fresh water. That's pretty cool.
It does also make you
means-
kind of rethink what we assume we know about the climate of the past, and how something like this can totally switch up climactic events and the reasoning behind them. And
Right. Yeah. And then on top of that, it can make you kind of think about, okay, at what point in time did this happen? What animals were evolving? And so if we're talking about, different fossils being found in the sediments, why are you finding freshwater fossils in this area as opposed to saltwater fossils? And, yeah. Creates differences. Pretty cool. Very cool. You want to hear about brains?
Always.
Brains! Yes, I have a story about a brain. Well, about brains. And then I have a story about feelings, because feelings are important too. And people want to know about feelings. So researchers have been trying to figure out where in our brain the neurons are that make us stop. So when you're walking and you realize you're going to accidentally step on something and you have to stop your step action, what are the neurons that stop your already planned action? What if you're in the middle of saying something, you realize you really shouldn't say that thing, so stop? Or you're driving and there's suddenly a red light and you have to stop. And then as you're sitting there at the red light, you're like thinking about going. And so your foot just comes off the brake pedal a little bit. And then you're like, oh, no, stop. There's neurons in our brain that are responsible for stopping actions, not just starting them. So starting the stop, it's not the start of a stop. It is actually a stop. And so there are neurons that are involved in switching your mode from go to stop.
This almost sounds like the underpinnings, the basis, the foundation, the baseline for free will.
Maybe a little bit. I don't know. Yeah, I mean, if you think about it at a very deep level, yeah. But there are neurons, and these researchers from Cedars-Sinai, they took patients who were have Parkinson's who were going in to get an implant put into their brain. So they're undergoing open brain surgery, and during the surgery, the researchers stuck electrodes into a part of the brain called the subthalamic nucleus. Now, this is an area in the basal brain, so this is not higher consciousness processing. This is basal level stuff. This is physical reactivity, reflex level stuff almost. And when they were making these people who have their brains undergoing brain surgery, had them watch a signal and wait for it to put the stop signal on. And then they tested different neurons in the area of the brain to see if there were neurons that changed their behavior when the stop signal was supposed to start. And indeed, they found single neurons that are responsible, that increase their activity when a behavior that has been started, like, I'm going to go push this elevator button. No, I don't want to. Before you stop that action of pushing the elevator button, there are single neurons in the subthalamic nuclei that are telling you to stop, changing the behavior.
It's so
Okay.
It's not it's not an
What
on-off switch. It's a brake and a gas pedal.
Yes, exactly. Yeah. And so these are the brake neurons. And then it gives your brain, it stops the signals, and then it gives your brain a second to start whatever the new action is. Whatever the next go action is.
So can we knock it out and see what happens?
Right. Well, that's their question, which is, there are, like in Parkinson's, there are diseases of brain-related movement disorders. And the question is whether or not these neurons are involved in these movement disorders and whether we can control them to control movement disorders. So there's some really interesting questions as to where this research is going to go with respect to therapeutics, whether or not there's going to be the ability to stop impulsive action. So in the sense of your free will, for disorders where there are twitches that are impulses that you can't control, is there something that can these neurons be recruited to control those disorders? We will see. Yeah.
How cool that people undergoing brain surgery are like, yeah, go ahead and do some science. Root around in there. While I'm open.
While my head's open, just stick some wires in there. Let's see. Yeah.
I have to say, I would. So I would too, but I feel like that's so rad. I just have to take a second, and everybody who participates in studies, in medical studies, thank you. Such a cool thing to do.
Yeah. Yeah. It's very, very cool. Agreed. All right. Now thinking of maybe, I don't know if this is a cool thing to do or not. Justin, you were talking about the thermal imaging of the marmoset faces to determine their emotional state. Well, researchers just published in the Public Library of Science PLOS One, a study in which they're using a deep learning framework to determine people's emotional state using wireless radio signals.
Yeah.
Get your tinfoil hats, everybody.
Yeah.
Yeah. So, if we have thermal imaging, right, that can detect blood flow changes. We also can detect things like changes in heart rate, changes in breathing that may indicate changes in emotional state. these researchers are using radio signals, bouncing them off of people to be able to measure heart rate and other physiological factors that are markers of emotion. And in this, it's
okay.
it can be good for monitoring people potentially. In the study, they used these wireless signals. They were tracking ECG recordings on people as they were watching movies, various videos, see how the people reacted, and then tried to measure those ECG signals distantly using radio waves. And they were successful in being able to do this.
That would be really helpful in the age of masks. Because I can't tell what people are doing with their face under the mask. Do you hate me? Are you happy? What's happening? Oh, this readout says you're frustrated with me. Why is that? Is it because I'm pointing radio waves at you?
Yeah, so their system was able to learn to identify fairly some emotions: disgust, joy, relaxation, fear, scariness, from radio frequency and ECG data. And potentially, I don't know, is this going to be tracking people in shops?
Yes.
As you're shopping,
Yes.
tracking people
Airports.
in movie theaters, in airports. Probably. These technologies are probably going to be used to track us for multiple different reasons. I like to think that, that this is the kind of thing that will come in handy, I don't know, at a speed dating, perhaps. I don't know.
So I guess part of the thing is, like with the algorithms for searches on the internet, whether you're Googling stuff or you're looking at, say, watching videos, or you're liking things in your Facebook thing or whatever, the algorithm starts feeding you things that it thinks that you would like also,
right,
that you would also consume,
yeah.
right? Being able to read somebody's emotional state and knowing their likes and their buying patterns on the Amazon or what have you, you can hit them with a comfort product ad or something like this right away. Like, all of these things are possible. There is also possible that there's a good life out there that we could all be living. A good arcs of emotional states and relaxation and things to get us a little bit more energized in sort of longer wavelengths than we are getting from our social media, that could potentially actually be applied to all of the technology that we have to make a more fulfilling life. However,
could you imagine a smart home that responds to you? So the smart home that knows to dim the lights and put on calming music. It gives you something to energize you.
You're probably right. Yeah.
Right.
But instead, you're right. You're likely going to be walking past a vending machine that's going to radio scan you and be like, "Hey, buddy, you want some sugar? You look a little down." Like, whatever. That's how my that's how my vending machine sounds. Everybody's vending machine will have its own voice specifically geared to them when they walk by. Yeah. But mine's like a carny from New Jersey. "Hey, buddy, hey, come over here a sec. Let me talk to you a minute."
Sounds like your vending machine used to sell cigarettes.
No, they did when I was a kid. That's how you got them.
Yeah, the research team says they do plan on working with healthcare professionals and social sciences on let me tell you, on public acceptance and ethical concerns around the use of this technology.
Oh, not on ethical applications, though.
Yeah, that's what I want to know.
What are your concerns? We just want to know how to diffuse your concerns, and then everything will be fine.
Exactly. Yeah, what is the actual practical use of this?
Well, I think there are many practical uses, and we've named several. But I mean,
but those are like capitalistic practical uses. Like, what's the For the betterment of society, medical.
Right. So if your devices, if your house is in tune with you and with it, and through deep learning has also learned your patterns. So if your house determines that you are stressed out, anxious, at a time when you don't really need to be, maybe your house can release calming essential oils and dim the lights. Or maybe if you are yawning at a time when you need to be energized and getting things done, maybe your house will automatically make you a cup of coffee. I mean, there are many different ways that a smart home, like a truly smart home, could respond to you and your needs before you even know you have them.
You know what I just thought of too is if there was something like this in classrooms, it could recognize when everyone was starting to fall asleep and not pay attention, be like, all right, now it's recess time. Go outside.
There was
okay, teacher, stop, teacher, stop. The kids need to go play.
Yeah, they're not listening anymore.
A movie from I don't know when, 1980-ish, called Mass Appeal. Anyway, it had to do with the people who were giving sermons, priests or something, being able to tell, to be able to rate it based on the number of coughs that they heard in the congregation. The number of coughs that they heard.
That's funny.
Would determine whether or not they needed to alter it or speed it up or make it a little bit more engaging. Because the coughs were the way people subtly disengage. But I was thinking of it less as, I like the smart house idea. That's a little, next level, okay, Google. Yeah. But I'm more talking about, haven't psychologists been working long enough in the field to have figured out the good arc, the healthy arc for human psychology? And can't we just be fed that healthy human arc?
The smell of dirt and trees? I don't know.
Whatever it is, yeah. It's like, hey, you need to go on a dating app, but this is not speed dating. We're really going to take a good look at who these people are and have some conversations over a long period of time to then realize that it's that person that you meet offline who's going to just knock you out of it. You just didn't see coming. But still, there's got to be a right way of doing things other than everything always being, let's market, let's get them to click, let's get them to engage, and then who cares what the result is? Because that doesn't sound like a healthy future.
Okay, one quick problem I see here is that this might remove the ability to feign interest or be polite. So I just think this is
politeness.
Yeah, so this is an opportunity to prevent people from being able to lie with their face, which sometimes is a good thing and sometimes would be terrible.
Wait,
for
you think
society.
It would work like a lie detector? Is it? Ooh.
I mean, it could.
No, I see that. Except lie detectors don't work.
There are people who train themselves to lie to. Yeah, you could train yourself for situations. Get yourself ready for performances in particular situations. I wonder though if this could replace wearables for so maybe you're working out at the gym or you're working out even in your basement or whatever. And instead of having a heart rate monitor on your wrist, your house just tells you your heart rate is 156 beats per minute.
You haven't gotten up in 3 hours. Go walk around.
Go walk around.
I don't want to.
Yeah,
please.
But maybe,
get up.
Maybe there is
I
some.
don't feel like it. It's time to get up. Then what does it do? Then it's like, don't make me. I'm like, oh,
I've taken all the chairs.
Wait, why did you take the chairs? I don't even know. Oh, I can't sit down now. Okay, I see it.
Okay.
Nicely done.
And that's when your bed just picks you up and throws you out. And on that note, oh my goodness, we've come to the end of our show. We have. And I'm not tracking anyone here, except maybe trying to keep track of our chat room. I do love our chat room. If you watch live, you can always join the chat room. Say hi if you do. I'm glad you're back, Justin. Thanks for coming back safely. I'm glad also that we have made it through the official Groundhog Day for 2021, even though every day may seem like Groundhog Day. It was the special day. 6 more weeks of winter, everyone. Everywhere.
We should be so lucky.
Okay, we've done it. We made it to the end of the show. I would like to shout out 2 people who helped the show. Fada, thank you so much for your help on show notes and on social media. Gord, thank you for keeping that chat room going. Identity 4, thank you for recording the show. And I would like to thank our Patreon sponsors for their generous support of This Week in Science. Thank you to Woody MS, Andre Bassett, Chris Wozniak, Dave Bunn, Vegard Chefstad, Hal Snyder, Donathan Stiles, a.k.a. Don Styler, John Scioli, Guillaume, John Lee, Ali Coffin, Gaurav Sharma, Shubru, Sarah Forfar, Darwin Handon, Donald Mundis, Stephen Albaran, Daryl Myshak, Stu Pollock, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Bentley the Translator, Big Nell, Kevin Reardon, Noodles, Jack Bryan Carrington, Matt Bass, Joshua Fury, Sean and Nina Lamb, John McKee, Greg Riley, Mark Hassenflo, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Data Pearson, Richard, Brendan Minish, Malazan, Johnny Gridley, Kevin Rails, back flying out, Richard Porter, Christopher Dreyer, Mark Massaros, Artyom, Greg Briggs, John Atwood, 2020 can bite my shiny metal arse. Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramus, Matt Sutter, Philip Shane, Kurt Larson, Craig Landon, Mountain Sloth, Jim Drapeau, Sarah Chavis, Alex Wilson, John Ratnaswamy, Stu Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Stanton, Paul Disney, Patrick Pecoraro, Gary S., Tony Steele, Ulysses Adkins, Brian Condren, Jason Roberts, and Dave Friedel. Thank you for all of your support on Patreon. And if you would like to support us on Patreon, well, you can do that. You just head yourself over to twist.org and click on that Patreon link. Next week's show.
We will be back Wednesday, 8 p.m. Pacific time, or Thursday, 5 a.m. Central European time, broadcasting live from our YouTube and Facebook channels and from twist.org/live.
Hey, do you want to listen to us as a podcast? Maybe get some stuff done around the house in your smart home while you listen. Just search for This Week in Science, where podcasts are found. If you enjoyed the show, please get your friends to subscribe as well.
Yeah, also, if you want any more information on anything you've heard us talk about here today, show notes and links to stories will be available on our website, www.twist.org, and you can also sign up for our newsletter.
You can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twist.org. Just be sure to put TWIS, TWIS, in the subject line, or your email will be spam filtered into the bottom of a freshwater, frozen
Arctic Ocean.
Nordic. It's the North Pole. It's kidney shaped. We talked about it.
You can also ping us on the Twitter, where we are at Twist Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world, so I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice, show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand, and all it'll cost you is a couple of grand. 'Cause this week's science is coming your way, so everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in science. This week in science. This week in science. 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 This week in science. This week in science. This week in science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. 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 And this week in science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's this week in science. This week in science. This week in science. 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 This week in science. This week in science. This week in science. 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 Got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This week in science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we said, then please just remember it's all in your head. Cause it's this week in science. This week in science. This week in science. 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 This week in science. This week in science. This week in science. 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 This week in 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 science.